Let us take a look of this problem called multiplication of large integer. Consider the problem of multiplying two very large n-digit integers here. For example, we have an integer a with 20 digit here. Similarly, with the b, also we have 20 digit here. These are very large, two integers a and b. As a common solution for this, uh, normally called the grade school algorithms here under the brute force design strategy. So in order to obtain the product of A and B here, so we need to multiply for each digit here and here until we finish for this and obtain the product of A and B. In terms of time, as you see here, this algorithm end up with n squared one digit multiplications. Next is we have another solution or formula for this problem multiplication of large integer for any pair of two digit numbers a equal to a1, a0 and b equal to b1 and b0. The product of c can be computed by this formula. C equal to a times b here and equal to c2 times 10 squared plus c1 10 power of 1 plus c0 here, where c2 is the product of a1 times b1 of the first digit and c0 is the product of a0 times b0 of the second digit, and c1 is the product of the sum of a digits and the sum of b digits minus the sum of c2 and c0. Let's say we have these two integer a and b, product of a and b here, where a equal to 2135, whereas b is 4014 here, and divide into a and b formula here, a1 b1 here. So a here is 21 times 10 squared plus 35, b 40 times 10 squared plus 14. So in terms of a times b here, so the formula end up with 21 times 40 times 10 power of square plus 21 times 14 plus 35 times 14 times 10 squared plus 35 times 14 here, based on this formula. Next is by using the same formula, but what we did just now, the formula based on the brute force design strategy. Now we aim to have a divide and conquer design strategy. Look at the formula here, which is actually the same formula what we derived before, but with here a times b, a1 times 10 power of and half here. This is we divide the digit n over the 2 plus a0 times another term here b1 times 10, another half and half here plus b0, and finally we have this formula where c2 equal to a1 times b1 is the product of the first half, and c0 a0 times b0 the product of the second half, and c1 is the product of the sum of the a half and the sum of the b half minus the sum of c2 and c0. So in general here, if a equal to a1 a2 b1 b is b1 b2, where a and b are n digit here, a1 a2 b1 b2 are n over 2 digit. We try to divide into 2 just now was 4 divided by 2 here, where divide by half digit. So become A1 times B1 times 10 power of n plus A1 times B2 plus A2 times B1, and the third term times 10 of n half here, and over 2 plus A2 times B. Based on the formula that we derived just now, and also the example of product of A and B, A times B, where A equal to 2135 and B equal to 4014. So in general, as we discussed just now, it will yield the A1 times B1 times 10 power m plus n A1 times B2 plus A2 times B1 times 10 power of n half plus A2 times B2. From the formula just now, from the recurrence perspective, for the numbers of one digit multiplication, m of n here, so we have a 4 multiplication, but this is multiplication of basically divide n digit over the 2 and half, and m1 return 1. So based on the master theorems, A equal to 4, B equal to 2, and D equal to 0, when we met to the condition here, we fall under condition number 3. A greater than A greater than B power of D, where end up with n log 4 base B. So base B is 2, 4. So it will returns 2. So finally, still end up with n squared, similar with the brute force design strategy, even though we apply for the divide and conquer. This is the second attempt using the divide and conquer design strategy for the same problems, which is multiplication of large integer, where we have A times B here, A1 times B1 times 10 power of n plus A1 times B2 plus A2 times B1 times 10 power of n half plus A2 times B2. And finally, for this idea, actually to decrease the number of multiplications, just now was 4. So the aim is to decrease it to 3. So this is the formula here, where we got this A times B, A1 times B2 plus A2 times B1 here, and finally we got this A1 plus A2 times B1 plus B2 minus A1 times B1 minus A2 times B2. So if we count how many multiplication here, we have 1, 2, 3, based on the second divide and conquer algorithm. So we reduce it to 3 multiplication, and finally end up with recurrent here, m of n, 3m, 3 multiplication of n over 2, which is a half of the digit, and m1 equal to 1. And based on the master theorems, so still that satisfies condition number 3 here. So we got this A equal to 3, B equal to 2, D equal to 0, and finally got n log 3 base 2, and log 3 base 2 approximately is 1.585 here, and this divide and conquer for the second divide and conquer algorithm end up with n to power of 1.585, which is less than n squared that we obtain using the brute force algorithm, and an attempt to apply the divide and conquer for the first divide and conquer algorithm also obtain n squared.